everyone, we're going to determine the limit of our sequence given. So let's get started, and we'll just take our limit as n approaches infinity of n plus 2 divided by n minus 2 to the power of n. Now, if you take the limit, you get 1 to the power of infinity, which is the indeterminate power. So what we're going to do is take the natural log of both sides of the equation. So we're going to set this to y equals the limit as n approaches infinity of n plus 2 divided by n minus 2 to the power of n. Now let's take the natural log of both sides. Ln of y equals the limit as n approaches infinity of Ln of n plus 2 divided by n minus 2 to the power of n. Since we have this n here, I can use my power of rules of natural logs and bring this in front. So I'm just going to bring that in front at this step here and write it like that. Now once you do that, you get this form, infinity times 0. So let's rewrite this n and pull it in the denominator. So with Ln of y equals the limit as n approaches infinity of Ln of n plus 2 divided by n minus 2 divided by 1 divided by n. And that's going to give you the form where we can use L'Hopital's rule. And before we do that, let's go ahead and expand our natural log as, let's write this as Ln of y equals limit as n approaches infinity, and write this as a difference of logs. So it's going to be Ln of n plus 2 minus Ln of n minus 2 divided by 1 divided by n. Now, before we get started, I'm going to go ahead and differentiate both of these pieces. So you might want to write that down and use L'Hopital's rule. So we're going to have Ln of y equals, and we're going to apply L'Hopital's rule, the limit as n approaches infinity, and then we're going to have 1 divided by n plus 2 minus 1 divided by n minus 2, all divided by the derivative of 1 divided by n is negative 1 divided by n squared. All right, so from here, we're going to simplify. So we have the limit as n approaches infinity, and let's get our common denominator for this. This is going to be n squared minus 4. And then go ahead and multiply these, and you're going to get n minus 2 minus n plus 2. Now this is just going to give you negative 4. When you distribute the negative here, this is going to be negative 4. And we still had in the denominator here negative 1 divided by n squared. All right, so basically I can just multiply this by n squared divided by negative 1. So we're going to write that down. Ln of y equals the limit as n approaches infinity of negative 4 divided by n squared minus 4. And instead of dividing, we're going to multiply by the reciprocal. So this is going to be negative n squared divided by 1. This is going to give me the limit as n approaches infinity of 4n squared divided by n squared minus 4. Now, since the degree in the numerator is the same as the degree in the denominator, the limit is the ratio of the coefficients of the highest degree. So that's just going to be 4 divided by 1, which equals 4. And that's for Ln of y. So basically, Ln of y equals 4. So let's simplify this because we want y, not Ln of y. So we have e to the power of ln of y equals e to the power of 4. This just means that this equals y. So we have y equals e to the power of 4. So e to the power of 4 equals your limit as n approaches infinity of n plus 2 divided by n minus 2 to the power of n. Thank you. Have a nice day. Bye-bye.